Hi, my name is Dave Duncan. I'm the business unit manager for DLP's enterprise and cinema display business at Texas Instruments. Welcome to ISE 2016. So a little bit about DLP. It was originally born all the way back in 1996, and back in those days we were actually using the components for the printing industry in addition to the products that you see here at ISE today. Namely both projectors for enterprise and education applications as well as cinema. But here we are today in 2016, and we are the world's leader in large display for digital cinema, all the way down to the smallest embedded Pico displays for handheld projectors, as well as the products that you'll see here in our stand, which are optimized for enterprise and classroom products. So originally, way back before 1996, when the DLP chip was in our labs, we were working on really two applications. The HD TV business was just starting to materialize, and we were actually funded by the U.S. government, an agency called DARPA, to see if our technology could be used one day for HD TVs. And the other application would be for printing. American Airlines and Southwest Airlines actually looked at us as an alternative printing process for their boarding passes to make them much, much faster. And from that we evolved into some traditional photo finishing type processing, but really ultimately realized that the benefit of DLP technology is actually for the projectors like you see at ISE today, and all the way up through digital cinema as well. So in the early days of DLP, the chips were quite large. And so for cinema applications that may be okay, and originally for some of our larger high brightness projectors that was okay. But the question is, how can you make it affordable for everybody, like you see not only at the ISE booth here, but also in applications that are embedded, like embedded cell phones, embedded still cameras, and embedded video cameras. And so one of the benefits of our technology is scalability. So we were able to reduce the size of the mirrors by half, and now even more than half the size. And so we're able to fit more of these chips onto a wafer, and that's the way TI essentially grows its business, is more chips per wafer means that they're ultimately more affordable, and they shrink in size, which means all of the components inside the projector shrink with the size of the chip. Yeah, so if you look at the chip inside a DLP cinema projector, it's almost 1¼ inches diagonal. But if you look at the chip in our very, very smallest Pico projectors, it's actually less than 1/10 of an inch. So that provides scalability and therefore affordability, not only with the DLP chip, but also the optics that are inside the projector. So along with the scalability of the chip itself, not only do we have more affordable projectors, but also you can pack more resolution onto those chips. So that's really how we've been able to scale from sub-VGA all the way up to the 4K chips that we're launching at this show. And then of course everybody keeps asking us, well, what's after 4K? So we all know the Tokyo Olympics, they're going to be broadcasting in 8K. So I can assure you that one of the things we're thinking about is how do we take further benefit of the scalability of our technology in order to move from what today is a 4K world to someday an 8K world, which of course should not be a problem for DLP, other than just sorting out when will it happen and make sure that we're ready when the market actually needs 8K resolution.